All right, strap in, everyone. We are diving deep into some pretty cool science today. You sent over this article from Popular Mechanics. It's called Scientists Are Pretty Sure They Found a Portal to the Fifth Dimension. And man, that title alone had me hooked.
Yeah, it's definitely an attention grabber. And, it's not just hype. This article highlights some really interesting research that could change how we understand the universe.
Okay, so let's start with the big question. What is this fifth dimension, and how does it connect to the mystery of dark matter?
Well, the idea extra dimensions has been around for a while now in physics. Back
Mhm.
in 1999, there was this model. It was called warped extra dimensions, or WED, and it tried to explain certain discrepancies in physics. Now, this new theory takes WED and applies it in a totally new way. It uses it to explain dark matter.
So they didn't just pull this fifth dimension out of thin air. There's a foundation for this idea.
Exactly. And to understand how this theory works, we need to remember that dark matter makes up a whopping 75% of the matter in the universe. It's like this invisible scaffolding that holds everything together. We know it's there because of its gravitational effects, but we can't see it. We can't interact with it directly.
Right, it's like a cosmic ghost. So how does this new theory try to explain dark matter?
That's where this fifth dimension comes in. So imagine our 3D world as a flat sheet. Now picture another sheet really close to it, almost touching. That's the fifth dimension. This theory proposes that certain particles, these are called fermions, and these fermions can travel between those two sheets. They travel through a kind of portal at the point where the sheets intersect.
Okay, so these fermions are like little travelers hopping between dimensions, but how does that explain dark matter?
Well, these fermions, when they're in the fifth dimension, they would interact with each other, creating what scientists call a dark sector. And the fascinating part is, this dark sector would behave exactly like the dark matter we observe, invisible to us, but still exerting a gravitational pull.
So it's like there's this whole hidden world operating right under our noses, and we've just been oblivious to it.
That's a great way to put it. And it gets even more interesting when you look at the details, the specific details of this interaction. The theory proposes that these fermions have what are called bulk masses. And these bulk masses allow them to interact in a very specific way. In the fifth dimension,
Bulk masses, huh? I'm guessing that's where the really complex physics comes in.
yeah, it does get a bit technical. But the basic idea is that these bulk masses are what differentiate the behavior of fermions in the fifth dimension from how they behave in our familiar three dimensions. They're kind of like a passport, allowing them to exist and interact in this hidden realm.
Okay, so we've got this pretty wild idea. Fermions are traveling through a portal to a fifth dimension, and they're creating a dark sector that we experience as dark matter. But wouldn't a fifth dimension also affect other forces, not just gravity? How does the theory account for that?
That's a really insightful question. And it's one of the areas where this theory gets really interesting and where it differs from other attempts to explain dark matter. You see, it suggests that the fifth dimension might only affect certain types of particles and forces, and only in very specific ways.
So it's not like this fifth dimension is just leaking into our world
Yeah.
all over the place.
Not necessarily. The theory is very specific about how this fifth dimension interacts with our world. It suggests a very subtle and limited influence, which is why it's been so difficult to detect.
This is blowing my mind already, and we've only just scratched the surface. What else is exciting about this theory? Is it just about explaining dark matter, or are there bigger implications?
Well, one of the things that makes this theory so compelling is that it has the potential to solve other puzzles in physics as well. For example, there's something called the hierarchy problem, which asks why the Higgs boson particle is so much lighter than expected. Well, this new theory suggests that the answer might be found in how particles interact with this fifth dimension.
So it's not just a one-trick pony. This fifth dimension could be the key to unlocking multiple mysteries of the universe.
Exactly. And that's why physicists are getting so excited about this new research. It has the potential to unify different areas of physics, and it could provide a more complete and consistent picture of how the universe works.
Okay, this is all incredibly fascinating, but let's get real. How do we actually prove this? We can't just walk through a portal and wave to these fermions in the fifth dimension, can we?
That would be amazing, wouldn't it?
Yeah.
But you're right, we need a more concrete way to test this theory, and that's where gravitational waves come in.
Now, how do we actually find proof of this hidden dimension? The answer might lie in something we've just started to detect.
Hmm.
Gravitational waves. How do those tie into this?
Well, gravitational waves are ripples in space-time. They're caused by the movement of massive objects. And this new theory suggests that the movement of those fermions in the fifth dimension could create subtle gravitational waves, waves that we might be able to detect.
So it's like we're trying to listen for the faint whispers of these hidden particles. And if we can hear them, that would be evidence for this fifth dimension.
Exactly. Gravitational wave detectors are still a relatively new technology, but they're becoming increasingly sensitive. It's like trying to hear a whisper in a crowded room. As our technology improves, we're essentially tuning out the background noise, and we're becoming better able to pick up those faint whispers from the cosmos.
This is incredible. It sounds like we're on the verge of a new era of scientific discovery. But before we get too carried away, I want to make sure we're all on the same page. Can we break down this fifth dimension theory one more time? I want to understand exactly how all the pieces fit together.
Absolutely.
Hmm.
Let's recap what we know so far. So we started with the mystery of dark matter, this invisible stuff. It makes up most of the matter in the universe. We can't see it, but we know it's there because of the gravitational effects that it has on galaxies.
It's like the universe is playing a game of hide and seek, and we're only starting to see what's hiding.
That's a great analogy. And this new theory offers a pretty good explanation for where dark matter might be hiding. A fifth dimension, right next to our own, but invisible to us.
So it's not some far-off galaxy or alternate universe. It's literally right here, just beyond our perception.
Exactly. Think of it like this. Imagine that you're an ant crawling on a piece of paper. To you, that paper is your whole world, a flat, two-dimensional surface. But what if there was another piece of paper, just a tiny fraction of an inch away, so close you couldn't even perceive it? That's the fifth dimension in this theory.
Okay, I can picture that. So we're the ants, and this fifth dimension is like that other sheet of paper.
Exactly. Now imagine there are tiny holes, or portals, where those two pieces of paper intersect.
Yeah.
Certain particles, called fermions, can travel through those portals,
Yeah.
moving between our three-dimensional world and this hidden fifth dimension.
So these fermions are like super-powered ants. They can access another layer of reality. That's pretty wild.
It is. And this is where it gets really interesting. When these fermions are in the fifth dimension, they interact with each other, and they create what we call a dark sector. And this dark sector, this is what we experience as dark matter, invidious, but exerting a gravitational pull.
Okay, so it's not the fermions themselves that are dark matter, but the way they interact in this fifth dimension.
That's right. And the key to this interaction lies in something called bulk masses. These bulk masses are specific to fermions in the fifth dimension, and they affect how they interact with each other.
You mentioned this bulk mass concept before. Can you break that down a bit further? It sounds pretty important.
Absolutely. Think of bulk mass as a property that governs how strongly particles interact with each other. In this fifth dimension, it's kind of like saying some particles are heavy in this fifth dimension, so they interact more strongly, while others are lighter and have weaker interactions. And this difference in interaction strength is important. It affects how much energy and momentum are exchanged between particles.
So these bulk masses, they determine how the fermions behave in this hidden dimension.
Precisely. And this is what makes the whole concept so elegant. By introducing this idea of bulk masses, the theory can explain why we only observe the effects of dark matter through gravity and not through other forces like electromagnetism.
That makes sense. So the fermions in the fifth dimension are interacting through gravity, which is a weak force. But because of these bulk masses, their gravitational interactions are amplified, enough for us to detect their effects as dark matter.
That's a great way to summarize it. The interplay between gravity and these bulk masses is what allows the theory to bridge the gap between the hidden world of the fifth dimension and the observable universe that we see.
This is all so mind-boggling, but it also makes me wonder, if this fifth dimension only affects gravity, does that mean that it has no impact on the other fundamental forces, like electromagnetism, or the strong and weak nuclear forces?
That's a key question. And it gets to the heart of why this theory is so revolutionary. You see, it suggests that our current understanding of fundamental forces might be incomplete, perhaps in this fifth dimension. These forces behave differently. Or maybe there are even new forces at play, forces that we haven't even discovered yet.
So this fifth dimension could be a whole new frontier of physics, with its own unique set of rules and laws. That's incredibly exciting.
It really is. And it opens up so many possibilities for future research. Imagine the breakthroughs we could make. If we could understand how these forces operate in this hidden dimension, it could revolutionize everything from energy production to communication technology.
Okay, I'm officially hooked on this idea, but before we get too lost in speculation, let's bring it back down to earth for a moment. How do we actually prove this? How do we move beyond theory and actually find evidence for this fifth dimension?
That's the million-dollar question. And it's why scientists are so focused on those gravitational waves we talked about earlier. They could hold the key to unlocking the secrets of this hidden dimension.
Okay, let's dive deeper into that. We touched on gravitational waves earlier, but how exactly would they help us prove the existence of a fifth dimension?
Well, imagine those fermions traveling back and forth through the portal. Between our world and the fifth dimension, their movement, especially with those bulk masses we talked about, would create ripples in space-time. Those are gravitational waves.
It's not just about detecting any old gravitational waves, it's about detecting specific patterns or signatures that would point to the existence of these fermions and their unique interactions in the fifth dimension.
Exactly. It's like trying to pick out a specific voice. In a crowded room, we need to filter out all the noise from other gravitational wave sources and focus on the unique signals that would point to the existence of this fifth dimension.
That sounds incredibly challenging, but is it even possible with our current technology?
It is a monumental task, but it's not impossible. Our gravitational wave detectors are becoming more sensitive, and scientists are developing sophisticated algorithms to analyze the data and search for those signs.
So there's hope that we might actually be able to hear these fermions as they move through the fifth dimension. That would be absolutely groundbreaking.
It would be a game changer. Imagine the headlines. Scientists detect first evidence of a fifth dimension. It'd be a paradigm shift in our understanding of the universe.
It would be like the scientific equivalent of finding a hidden door in your house, a door that leads to a whole new world. But let's not get ahead of ourselves. What are the specific types of gravitational wave signals that scientists are looking for? How would they know for sure that they found evidence of this fifth dimension?
Well, one promising avenue is to look for what are called resonances. These are specific frequencies of gravitational waves that would be produced by the fermions as they oscillate between our world and the fifth dimension.
So it's like each fermion has its own unique hum or vibration. And if we can tune in to the right frequency, we might be able to detect it.
That's a great way to think about it. It's like searching for a specific radio station on the dial. We need to scan through the frequencies and look for those distinctive peaks or resonances that match the theoretical predictions for these fifth-dimensional fermions.
That sounds like a pretty daunting task. Are there any specific projects or experiments that are actively searching for these signals?
Absolutely. There are several cutting-edge gravitational wave detectors around the world that are constantly collecting data. One example is LIGO, the Laser Interferometer Gravitational Wave Observatory, which has already made groundbreaking discoveries in recent years.
So the same technology that allowed us to detect gravitational waves from colliding black holes could potentially help us unlock the secrets of a fifth dimension.
Exactly. It's amazing how scientific advancements often have unexpected applications. What was once considered purely theoretical is now within reach of experimental verification. It's a testament to the power of human curiosity and ingenuity.
This is all so inspiring, but I'm also curious, even if we do detect these gravitational wave signals, wouldn't there be other possible explanations? How could we be absolutely sure that they're coming from a fifth dimension and not something else?
That's a great point. Science is all about testing hypotheses and ruling out alternative explanations. In this case, scientists would need to carefully analyze the characteristics of the gravitational wave signals, like their frequency, amplitude, and polarization, to see if they match the predictions of the fifth dimension theory.
So it's not just about finding any old signal, it's about finding a signal that fits the specific fingerprint predicted by the theory.
Exactly. And that's where the real scientific detective work comes in. It requires a deep understanding of both theoretical physics and experimental techniques to tease out the subtle clues hidden within the data.
This is all so fascinating, but I can imagine some people might be skeptical. After all, this is a pretty radical idea. How are physicists responding to this theory? Is it gaining traction in the scientific community?
It's definitely generating a lot of buzz. While the theory is still relatively new, it's already sparking debate and discussion among physicists. Some are understandably cautious, emphasizing the need for more experimental evidence.
That's fair. Extraordinary claims require extraordinary evidence, right?
Absolutely. But many physicists are also excited about the potential of this theory to revolutionize our understanding of the universe. It's a bold and imaginative idea that could open up entirely new avenues of research.
It's like a fresh breath of air. In the sometimes stuffy world of theoretical physics, it's reminding us that there's still so much we don't know, and that the universe is full of surprises. But let's not forget, even if this theory turns out to be wrong, the search for dark matter will continue.
That's right. The quest to understand dark matter is one of the biggest challenges in modern physics, and it's driving incredible innovation and creativity in the field.
It's like a cosmic treasure hunt.
Mhm.
And the prize is a deeper understanding of the universe itself.
And the journey is just as important as the destination. Each new discovery, each new theory, brings us closer to unraveling the mysteries of the cosmos.
This has been an incredible deep dive so far. We've explored the mind-blowing concept of a fifth dimension, learned how it could explain the mystery of dark matter, and discussed the cutting-edge research that's underway to prove its existence. What else can you tell us about the potential implications of this theory? If it's true, how would it change our view of the universe and our place within it?
That's where things get really philosophical and perhaps a little bit scary, you
Mhm.
know. If this fifth dimension exists, it means that our perception of reality is fundamentally limited. We're like those ants on a piece of paper, completely oblivious to the vastness that might lie just beyond our reach.
It's a humbling thought, isn't it? To realize that we might just be scratching the surface of what's truly out there.
It is, but it's also incredibly exciting. It means that there's so much more to discover, so much more to learn about the universe and our place within it.
This is giving me serious existential chills. But I'm also feeling a sense of awe and wonder. It's like we're standing on the threshold of a new era of scientific discovery, and the possibilities are endless.
Exactly. And who knows what other secret of the universe holds? Perhaps there are even more dimensions, beyond the fifth, realms of existence
Mhm.
that we can't even begin to imagine.
Wow, that's a mind-blowing thought.
Yeah.
So this fifth dimension might just be the tip of the iceberg. There could be a whole multiverse out there, teeming with possibilities.
It's certainly a possibility.
Yeah.
And that's what makes science so captivating. It's a never-ending journey of exploration and discovery.
Well, I, for one, am eager to see where this journey takes us. This has been an absolutely fascinating deep dive, and I know our listeners are going to be blown away by this incredible theory. But before we wrap up, I want to make sure we leave everyone with a clear takeaway message. Can you summarize the key points of this fifth dimension theory and what makes it so groundbreaking?
Absolutely. The key takeaways are that this theory offers a potential explanation for dark matter. It introduces the concept of a fifth dimension, a hidden realm right next to our own. Certain particles, called fermions, can travel through portals to get there.
It's like finding a secret passage in your house, a passage that leads to a whole new wing you never knew existed.
Exactly. And in this hidden dimension, those fermions interact in a unique way. It's because of something called bulk masses, and they create what we call a dark sector. This dark sector is what we experience as dark matter.
So it's not just the dimension itself, but the special rules and properties within it that make this theory so compelling. What else makes this theory so groundbreaking?
What's really intriguing is that this theory doesn't just try to explain dark matter. It also might be able to solve other long-standing puzzles in physics, like the hierarchy problem. Why the Higgs boson particle is so much lighter than expected. This fifth dimension could provide a whole new framework for understanding fundamental forces in particles.
So it's not just a one-hit wonder, it's a potential paradigm shift in physics. What's really exciting is that scientists might be able to detect this fifth dimension by looking for specific signatures in gravitational waves, those ripples in space-time.
Right. The idea is that the movement of those fermions between dimensions would create unique gravitational waves. And we could potentially detect them with instruments that are getting more and more sensitive.
So it's like listening for the whispers of this hidden dimension,
Hmm.
hoping to catch a glimpse of what's happening just beyond our perception. This is absolutely mind-blowing stuff. It really makes you question what else might be out there.
It certainly does. This theory reminds us that our understanding of the universe is constantly evolving, and there's always more to learn. It sparks the imagination, and it makes you wonder what other secrets the cosmos might be hiding.
It's like the universe is beckoning us to explore further, to push the boundaries of our knowledge and imagination. But let's come back down to earth for a moment. What does this all mean for the average person? If confirmed, how might this discovery impact our everyday lives?
That's a great question. and it's hard to predict with certainty. But historically, major scientific breakthroughs have often led to technological innovations that have transformed society. Think about electricity, the internet, or even GPS. These technologies came from fundamental discoveries in physics.
So you're saying that this discovery, if it's true, could pave the way for new technologies, technologies that we can't even imagine right now.
It's definitely possible. This deeper understanding of fundamental forces and dimensions could lead to breakthroughs in energy production, communication, computation, even transportation. Who knows, maybe one day we'll even be able to harness the power of this fifth dimension. We could use it for practical applications.
Now that would be a game changer. It's incredible to think that something so abstract and theoretical could have such tangible impacts on our lives. But let's be realistic. This is all still very much in the realm of theory. What are the biggest challenges or hurdles that scientists face, in proving or disproving this theory?
One of the biggest challenges is simply the complexity of the theory itself. It involves advanced concepts in theoretical physics, and it requires sophisticated mathematical models to make predictions. And even if the theory is sound, actually detecting those faint gravitational wave signatures is a monumental task. It'll require incredible precision and ingenuity from our scientists and engineers.
It's like searching for a needle in a cosmic haystack, right?
Exactly.
Yeah.
But that's what makes science so exciting. It's the thrill of the chase, the relentless pursuit of knowledge, the drive to solve the universe's greatest mysteries. And even if this particular theory doesn't pan out, the journey itself will undoubtedly lead to new discoveries and advancements. Discoveries and advancements that will deepen our understanding of the cosmos.
Well said. That brings us to the end of our deep dive into this incredible theory. It's been a wild ride. We've explored the mind-boggling concept of a fifth dimension. We learned how it could explain the mystery of dark matter. And we discussed the cutting-edge research that's underway. Research to prove or disprove its existence.
It's been a fascinating journey, and I hope it's inspired our listeners to think about the universe in new and exciting ways.
I'm sure it has. And if this deep dive has sparked your curiosity, I encourage you to delve deeper into this topic. Explore the vast amount of information and research that's available.
There are so many resources out there. Books, articles, websites, even other podcasts. They can help you learn more about this fascinating theory and the broader search for dark matter.
And who knows? Maybe someday you'll be the one to make the next groundbreaking discovery, the discovery that unlocks the secrets of this hidden dimension. But for now, I think it's time to let our minds rest and digest all this incredible information.
Agreed. Sometimes the most profound discoveries require time and contemplation to fully sink in.
Well, on that note, we'll leave you with one final thought. If this fifth dimension does exist, what other secrets might it hold? What other forces, particles, or even life forms might be lurking just beyond our perception? It's a question to ponder, isn't it? Keep looking up, keep exploring, and never stop questioning the nature of reality itself. Thanks for joining us on this incredible deep dive.